what you've heard today has been a pretty good logical progression in deciding whether or not you're able to put a plantation in here, how to manage it and grow it, and all the hoops you might have to jump through to get it to a final product. And maybe as you've been listening here, you're thinking about your own situation as a practitioner or a regional manager, municipal planner, whatever, and you're going through your mind, and 3 years have passed, or the name might have thought that 3 years have passed sitting here, but you've got these trees, and now you're not sure what to do with them. Well, I hope to be able to give you a few options on how we have in the past done things, and options that are relatively easily accessible to handle woody biomass. A lot of what I'm going to show you are basically pictures. We recently did a harvesting demonstration at Whitecourt in December, and a lot of the pictures are taken from that demonstration. So that's basically what my presentation will be about. So as I mentioned, I'll be focusing on two main topics of harvesting and product handling. While talking about harvesting, I'll touch a bit about plantation layout, which Richard has mentioned a bit about as well already. The types of machinery that are commonly used and easily accessible. What you're hoping to accomplish in your harvesting. And then in the product handling side, I'll look at the different types of products that are produced from each of these pieces of machinery, and some ways of handling it, that product. So this is our basic two-row bed design. The dimensions vary from site to site, place to place throughout the world, but this is the most readily accepted design. There are other three-row designs and other things like that, but this is basically what we are having to deal with. My talk, I'll be talking mostly about the high-density plantations, the short rotation intensive culture plantations. We have mentioned the afforestation settings where there's a lot lower densities, around 1,000, 2,000 stems per hectare. What I'll be focusing mostly on is the short rotation intensive culture. You can see that it's a very structured row design, strict spacings between rows and within rows, and that's critical in choosing the implement you want to use to harvest. Just a little bit about afforestation plantations. If you were to do something like that, like Ainsworth is doing up in at our Claremont site, that is for a different purpose, growing a larger size tree for a dimensional size trees with which you would use traditional logging harvesting practices. Harvesting, well, as you can see here in the diagram as well, the solid or the solid dark line through the middle of the two-row bed is where we normally place our irrigation line. Normally we've done it subsurface, and as Richard mentioned, we will be installing an above ground system this year. Looking at harvesting that, if you have a below ground system, harvesting is usually done in the winter, so concerns about compaction or breakage of any pipes underground, the frozen soil conditions should allow for heavy machinery to go on without any consequence. So, and with above ground systems, you would simply remove that above ground lateral, harvest, and then roll it back out again. So it's very easily to work around that kind of system.
Well, we actually don't. We harvest above it.
You harvest above it?
Never remove them.
Never remove it. Interesting. Okay, good to know. So, we'll get on with types of machinery here. There's basically two different scales of machinery. Large scale that are really available and a small scale. What we have here is I would consider a large scale harvesting machine. It's a modified modified forage harvester, sorry. This one, the one with the green one here, sorry, is a class harvester, standard forage harvester with a modified harvesting head. It's a HS2 wood harvesting head, mounts directly on a very wide range of series of class Jaguar forage harvesters. Very little modification necessary to attach this to the machine. A few extra bolts or holes need to be drilled into the machine to mount some things, but other than that, very easily to put on. And as you can see in the top left-hand side, two circular saw blades cut the stump off at whatever depth, height you've set it at. Fingers feed the woody material through the chopper and spits it out the chute and into a silage bin that's trailing the harvester.
There's a pointer on there, the yellow button mark.
Thanks. Much like any other forage operation that you've seen in the province or anywhere else. You might think that passing woody material through the internal chopper system of the harvester would cause damage, or need modification, but normal grass cutting chopper knife arrangement on these is all that's needed, no adjustment necessary. Another added feature of these types of systems is you can vary the chip length with the touch of a button. It's all computerized. You can modify that as easily as you would in any other forage harvesting operation. In our demonstration in December, the speed with which this machine travels is remarkable. We had it up to 9 miles an hour, which I thought was just, it was like running alongside of it, quite remarkable. Klaas is not the only one who develops a wood cutting head. The machine here on the bottom left is a case harvester, which is a little larger than the Klaas, but does the exact same operation. In case you haven't noticed, it produces chips, wood chips. Sorry. Second machine I'd like to talk about is a small-scale harvester. It's called the JF192 harvester. Again, basic concept similar to the previous one, only it's small scale, like I said, single road, takes one row at a time. Again, specifically designed for row crops. It's a little slower, but again, the system is basically the same as any forage harvesting operation. One thing I forgot to mention about the modified forage harvester is it is specifically designed for a 2-row harvesting pattern. It has, as you can see, it has sweeps here that funnel material directly into the chopper area. And the last piece of machinery I'd like to talk about is a bale system. The one shown here is the baler by Anderson out of Quebec. It basically produces a round bale, just like anything you've seen in the agricultural regions around Canada. It's quite a bit beefed up, as you can tell by the teeth here on the cutter, but straddles, takes in 2 rows quite easily as well. The main difference here is it isn't limited to a row crop system. It can be used in an open grown system. There's others that were mentioned before, like the Fecon chipper, which can also be used in possibly open grown or native willow settings, like Jack was interested about. So that's one thing that makes this a little more flexible. As for wrapping, you can use standard twine to wrap the bale, or there's also, it comes with a netting system that can also be attached to it. Typically the bales that it produces range from around 500 to 600 kilograms each, and quite easily handled with normal equipment. It's mounted behind the trailer and can be offset either to the left or to the right, or ride right behind you. So there's flexibility there in how you're harvesting your system. A little bit about the costs of each one of these pieces of machinery. Again, they're relative to the scale that you're harvesting. So the Claas forage harvester that I mentioned, it fits most common models of the Jaguar series. The one we had it mounted on was the 8870 model. Rough price is around $160,000. That includes tires that are mounted onto the forage harvester, prep puncture resistant forestry tires. So the next in line was the JF, which, as you can tell by the price, is for a more smaller scale operation, around $40,000. It requires about 150 horsepower to operate off the 3-point hitch. And there's the baler, which requires a considerably larger tractor than the JF and has a price tag of around $140,000 just for the baler. So this price is just for the head with the tires. This price is just for the harvester itself, no tractor included. And here, again, the price of just the baler, no tractor included.
What was the power take on speed on this?
I could find that out, but
it'll be 1,000 RPM.
So, what should your harvesting try to accomplish or look like in the end? I guess from our experience, it kind of depends on what the crop looked like to begin with. Certain machines operate better under certain forms of growth. As you can tell, some possibly, depending on the growth, leave a little messier than others, but this is typically what you would like to see happen. As we're harvesting in the winter, snow can become an issue. We noticed that a little bit with the baler, with snow coming in. Trying to wrap the bales is a little difficult, but as the machine warms up, it usually works itself out. Another issue jogged my memory as presentations came along this morning was the issue of pollutants being taken up by the plant and stored in the leaves. Typically we harvest in the winter with leaf off. It's good if the plant can take up the nutrients, but if we don't take the nutrients off site, it's still there causing, it's still there. So an option to remove sites, if that's your main goal in growing your crop, is possibly harvesting with leaf on, taking it off site then, and dealing with it if you have a known pollutant on your site. So that's one option of how to mitigate that kind of problem. So just a few pictures of what types of products we've produced. chips here in the top left corner, bales here, and chips made from bales. One of the main important things about chips is quality, and so quality can be both of the wood quality itself, but also of the size distribution. Depending on the type of system you're feeding, it may or may not accept different sizes. So you may have to keep that in mind when figuring out which harvesting option or heating or combustion option you're looking at. So bales can be used as is. They dry themselves naturally, left out in the field. I've read and heard 2 to 3 months, and they can be dried with little or no help on their own. If you have a bale furnace, they could be shoved right in there and used as they are. Otherwise, other systems, you would need to chip them as well, and for that you would need a bale buster or a tub grinder or that sort of piece of equipment. That's good. So here I just have a few pictures of a typical tub grinder here, loading a bale into it. Here's our stack of bales from our harvest in Whitecourt, another tub grinder picture. And again, you can have different scales of chip drying or chip storage. Here being a quite large system with conveyors and that sort of thing, and up to a small scale system where you need a bobcat and some other things like that. So typically, initial moisture content of your wood chips is around 50% roughly. For normal operating or operating usage, you would want them closer to around 20% to get the most efficiency out of it, like you've heard previously in the last couple days. So how do we get as much water out of those chips at the lowest cost? We've heard different options of combining different waste heat to dry chips. If that's not an option for you, possibly what we have set up here on our site in Edmonton might be of interest to you. We're trying to use off-the-shelf basic grain drying equipment that is readily available to dry the chips. As you can see, sort of a progression of the building of this type of a system. We have our perforated ductwork here, which is attached to a 18-inch 3-horsepower axial fan that blows air through the system and disperses ambient air out. We just cover up that pipe with our chips, and here we get our finished chip pile product. We're monitoring it for temperature and moisture. We have noticed temperatures getting up into the range of 50 degrees Celsius within the pile at varying depths. We have covered it to keep excess moisture off and that sort of thing. So the system, we've noticed, works quite well. If tracking temperature is any indication of airflow, our probes throughout the pile show that once we've kicked on the fan, different temperatures track ambient quite well. So we know that that airflow is working. So the rough cost of something like this, I think we put it together for under around $5,000. So it's a one-time cost that you might be able to serve your purposes for many years to come.